Hello, I am Dr. Baldwin Immanuel from Amet University. I am working as Associate Professor in AAA Department. Actually, today I am going to explain you about the topic measurement of insulating resistance. First of all, we have to know what is insulation resistance. Why do we need to know what is insulation resistance? Insulation resistance is nothing but resistance value. Actually, if you see a wire, any wire, if you take the wire, you have a conductor and it will be separated by a insulation medium. Okay, this insulating medium will be having some resistance. What is resistance? Resistance is a property of a material to oppose the flow of current. Sir, why I have to oppose the flow of current? Actually, we generate power in order to transmit it and use it. Okay, therefore, why we want to use the insulating medium or resistive medium? See, I have, for example, we have three-phase power. I have a three-phase motor. If it is a three-phase motor, three wires will be there, R, Y and B, three-phase wire. Therefore, three phases will be given. For that, I have to use the conductive material. Conductive material, what is conductive material? Conductive material are material which used for conduction of the current. Okay, or flow of electrons. Okay, for this I need three sets of wire. Therefore, these three sets must be separated, and it should be separated such that if I am going to keep my hand, I should not get any shock. At the same time, the phases R phase and Y phase should not be short circuited. In the previous lecture, you might have heard about the circuits. In that circuits, we saw what is short circuit, what is open circuit and things like that. See here, if we are going to give three-phase wire connection, then we need the wires to be separately given to the motor. Okay, therefore, if I am going to keep my hand also, I should not get any shock. If that is the case, I need the insulation value. This insulation value depends according to the wires. If you see this wire, the insulation value is very less compared to the wire which is being used over here. See here, the insulation thickness is very large. Okay, therefore, according to the applied voltage, the applications, we change the wires. If you see the laptops or if you see the system PCs, where the wires thickness will be very less, there the insulation is very less. That means the voltage which has been applied or which has been applied for that particular wire will be very less. And why do we need to know the insulation resistance? See, if you are not going to know the insulation resistance, there may be a fault in the wire. If that is the case, short circuit will be there. If short circuit has been there, there will be losses. How the losses will be there? We know that current is equal to I is equal to V by R. Okay, at the same time, the losses will be equal to I square R. I square R means if the current is more, according to the first equation, I is equal to V by R means for short circuit conditions, the current value will be very high. If the loss is I square R, if the current value is high, this I square R will also be very high. If that is the case, we are going to waste the generated power. We should not waste the generated power because we are already in deficiency of the power. Therefore, we have to know what is the insulation value, how it has been operated, whether the power has been used efficiently or it has been wasted. At the same time, if you see the operation of a motor, this motor has to be checked before going for the operation. See, this college is mainly meant for marine engineers as well as the students who study over here generally focus to go in the field of marine. That means in the ship, if a ship is going for a voyage, the voyage will be a minimum of 6 months or 1 year. Okay, if that is the case, if I am going to take this machine, this motor in my ship, then I am believing that for the entire 6 months or 1 year or 1.5 years, this machine will work. How it will work? Therefore, I have to check that whether it is in good condition. For that, I need to measure the insulation resistance. Actually, the cable thickness and the insulation wires for different cables have been showed in the slide. If you see the next slide, you will be easily understanding that why do we go for this test and why do we, it's important for us, or it's today's topic for going to the slide. Okay, if you see the slide, the cable which has been damaged. Okay, in the first diagram you have the cable which has been damaged by some external agents, that is sometimes it may be torn by some rats or some people might have cut the cable wires. Okay, in that case also, if you see the diagram, it will be clearly seen that the two phases, that is, if in that diagram you have 3-phase wires. Okay, like this you have 3-phase wires and some 2 phases are being damaged. If the 2 phases are being damaged, automatically short circuit may occur. Okay, which will lead to short circuit fault, that is high current will be flowing and it will be wasted. Okay, and in the second diagram also it is clearly seen that because of some burn or things like that, the wires has been damaged. See, we won't go and check all the wires all the time. Okay, and it's not our duty also. We are here to readily work. In today's world, we are very fast and we want to utilize, or we want to use things in a maximum extent in a shortest duration. If that is the case, I want my machines to be operated with a fast manner and I don't want to waste the power. Okay, therefore, if this is the scenario which is within, then we will not be able to use the power effectively. Okay, at the same time, the accuracy of the machine will also get damages. For that, you have the second diagram which tells you that the wires will be in the center part. See, in this cable, if you see, the center part is the conductor and the surrounding part will be the insulator. Okay, therefore, you have to know the thickness of the insulator. For example, if you have a paper is also an insulator. See, if you are going to have a paper like this and if you are going to apply a voltage, okay, this voltage, if the 2 wires which has connected with the polarity, supply polarity, this will not conduct because this is an insulator. The center part is an insulator. But if you are going to increase the voltage which has been applied at one junction, this insulator will break. Okay, the insulation will break. At that junction, the current will be flowing through the circuit. If that is the case, the insulator which we are going to use, which we are thinking that it's insulating, will not be acting as an insulator, will be acting as a conductor, because the insulator is already been punctured. Okay, that has to be justified, or that has to be confirmed with the help of some suitable equipments. For that only we have that diagram. See, as I told you earlier, in the marine field, when we go, we rely on machines. For generation of power, we don't get the power from the land. Okay, here in the land, if you see, we have power generation stations where we generate the power, and this generated power will be transmitted, and this transmitted power will be distributed according to the applications or according to the requirement of the consumers. But here, as we are going for a voyage, okay, in the ship, the power which is being needed in the ship is only generated within the ship itself. That means we have the generator or the alternator within the ship where we generate the power, and the power will be distributed and it will be utilized within the ship itself. Okay, if that is the case, I don't want to waste the power which is being generated within. for that only we go for safety and security measures. Okay, I'll explain you. If you are going for a 3-phase motor, if I am going for a 3-phase induction motor or 3-phase machines, then I'll be having 3 windings. If you see the motor winding, see the windings are totally, it's been it seems that it's all the windings are short circuited, or all the windings are lapped one after the other. But here the enamel wire is being used, therefore short circuit will not be happening in the wire. But in some cases, because of some movements, or if we are going to meddle, or if we are going to do some work within the windings, at that time sometimes the winding, the insulation may get damaged, or because of the application of some high voltage, the insulation may get punctured. Okay, if that is the case, if we can't identify that this is the winding, this is the place where short circuit has happened. If short circuit has been happened in the winding, then automatically the system will be taking more power and wastage will be more. The system will be heated up and the efficiency will not be good. So that what have to be done? If you see in the right hand side diagram, there will be a small box which will be called as a terminal box. See, in the first winding you have the wires, 3 wires which are being coming out. These 3 wires will be connected with the terminal box, where the winding will be within the machine, and here if you notice there will be 6 slots. It's a 3-phase winding. You will be having the winding, 3 windings, 1, 2 and 3 windings. We will tell it as R phase, Y phase and B phase. The output, or in the terminal box there will be 6 terminals, 1, 2, 3, 4, 5 and 6. But it will not be named as 1, 2, 3, 4, 5, 6, but it will be named as U, V, W, X, Y and Z. U, V, W are the one side or starting point of the windings. Okay, for windings R phase, Y phase and B phase. For the ending terminal you will be having as X, Y and Z. Okay, in the box, in the terminal box, if you notice it clearly, it will be given like that. Okay, if 3-phase winding is being given, what are things have to be done, or what are the types of connections which has been available, and then if we know the connections only, we will be knowing which terminal comes in which point. Okay, if that is the case, we have to know there are 2 types of connection. One is star connection and the second one is delta connection. What is star connection? What is star connection? Star like structure. That means, sir, I can short circuit all X, Y and Z, and I will be giving U, V and W separately. It will be like this. See, 3 windings, first winding, second winding and third winding. Okay, the one point is being connected as star. Okay, it's been shorted and the other ends are left free. This is like a star, therefore the connection will be like this. X, Y and Z will be short circuited. You will be giving supply. If it is a motor, you will be giving supply to U, V and W. If it is a generator, you will be taking supply from U, V and W. What about this star? What about the delta? How it will be? Therefore, it should be like a delta type connection. Okay, therefore 3 windings will be there. It should be connected in delta. That means, see this 3 windings, 1, 2 and 3. 3 windings, we have 3 sets of terminals. First winding U and X, second winding V and Y, third winding W and Z. I will remove this connection so that it will be easy for us to remember things. Okay, if this is a starting point, first winding is U. Okay, starting point of R phase. The ending point of R phase is X.
Okay, the starting point of Y phase is B, ending point of Y phase is Y, starting point of B phase is W, ending point of B phase is Z. If I am going to short circuit, I am going to short circuit X and V. Okay, I am going to short circuit Y and W. I am going to short circuit U and Z. Therefore, this should be the terminal connection for easy connectivity 1, 2 and 3. This it will be written as U, V and W. This will be making the starting point of the winding. At the same time, ending point of the winding will also be there, which is X, Y and Z. Okay, Y will be connected with W. Is it right? Therefore, W, Y. Okay, X will be connected with V. Therefore, X with V. Okay, and Z will be connected with U. Z will be connected with U. This will be the terminal connections for a 3-phase machine. See, here it's the terminal connections are made like this because if we want to have a star type structure, if we want to make a star type structure, it will be easy for us to short circuit this X, Y and Z. Okay, it is easy for us to short circuit X, Y and Z. Therefore, you will be taking wires from U, V and W. Therefore, it is star connection. If it is a delta connection like this, the connection will be, see, this should not be short circuited, but instead of that, what I have to do, X should be connected with V. X should be connected with V and Y should be connected with W. Y should be connected with W and Z should be connected with U. Okay. Therefore, 3 wires can be taken out. Okay. Here the connection, making of connection is somewhat difficult. In order to make it easy, they will be making the connection like this. See over here in the terminal box itself, they are making the connection that U and X are R phase. Okay, diagonally it's been placed. V and Y are Y phase. Okay, and W and Z are Z phase. That is a B phase, sorry, B phase. 3 phases. Therefore, here for star connection, I told you that these 3 terminals can be easily short circuited. In case of delta connection, I will be connecting Z and U, X and V, Y and W. See, map it, the same mapping will be there. See, U and Z. Therefore, straight line, anyone can easily connect it. No one should memorize it or no one should have a diagram and tell, yes, this should be connected with this wire and things like that. No confusions. Any worker or any person, if you are going to tell, connect it in a parallel manner, automatically you will make the connections. You can take one wire and take it as R phase, second wire you can take it as Y phase and third wire you can make it as B phase. This is the connection. Okay, now we are going for how to measure or how to test the machine. Okay, I have the machine, now I know how the connections are being made, whether it is star connection or delta connection, how it is being made, I have known. Now I have to know how the readings are being taken or what is the instrument I have used. Okay, how the instrument works. For working the machine, for measuring the insulation resistance, I have a special instrument which is called as Megger. Okay, this mega ohm resistance. Okay, mega ohm resistance. Now we will see the diagram. We are going to explain what is Megger. Megger is an instrument which is used for measuring the resistance, mega ohm resistance or insulation resistance. Since it's mega ohm resistance, therefore it is a collective of, or it is a combination of ohm meter as well as a generator. See, ohm meter or meter which is used for measuring the resistance. See, for wherever we have the ohm meter or resistance measurement, we will be having a DC source or supply which is been connected within, okay, or we will be having a battery. Okay, here instead of battery we have a generating unit, we have a DC generator which is been connected within. Therefore, a generator set is been connected and we have a resistance circuit which has been available, which is none other than the ohm meter. Therefore, here it's a generator operation. Generator, how the generator operates? See, we have a conductor. Whenever a conductor cuts a magnetic field, EMF will be induced in a generator. Therefore, this is the armature conductor. Okay, we have north pole and south pole. Therefore, this conductor is being placed in between the magnetic field. Okay, now if the conductor is being rotated, okay, therefore if you see the megger, instrument megger, you have a crank. Okay, this crank, if you are going to rotate this crank, automatically the armature conductor which is being placed in between the magnetic field will be rotated. As the conductor rotates, it cuts the magnetic field, and the magnetic field is cut, EMF will be induced. This EMF will be appeared across the terminals T1 and T2. Okay, for better accessibility or for varying the range, we have the selector switches so that the ranges can be varied. Okay, therefore this voltage has been appeared. Now how to measure the resistance? For measuring the resistance, we have we know the formulas that R is equal to V by I. Okay, R is equal to V by I. V is nothing but the voltage. The voltage is nothing but the EMF which is being developed within this generator. Now the current, when the current will be flowing, or in which circuit current will be flowing? Whenever we have a closed path, then current will be flowing. That means these two terminals T1 and T2 should be connected to a closed path, then only the current will be flowing, and it will be measuring the voltage. How the measurement of the voltage will be done means, see, we have a current coil CC and we have a pressure coil which is PC. Okay, these two coils, current coil is a coil which measures the current. It will be connected in series with the circuit. If you see the circuit, it will be connected in series with the circuit, and pressure coil is a coil which will be connected in parallel with the circuit. If you can notice, R2 through R2 as well as through L, it's been connected in parallel to the circuit. Okay, therefore these two magnets will be producing the flux, and this flux will be making the pointer to rotate. Okay, therefore the deflections will be done with the help of this pointer, and because of the current coil as well as voltage coil. That's the operation of a ohm meter. Now what is the circuit? If you see the megger also, see, if in the megger instrument we have two terminals, one is earth and another one is line terminal. Therefore these two terminals are the terminals which have been connected, marked over there as T1 and T2. If these two terminals are connected to a circuit, see, for example, I will be connecting a wire. I'll show you a real time example. See, this is a phase U, V, W, as well as this is X, Y and Z. I'll take the same color so that it will be representing the same phase, R phase. Therefore, if it is R phase, a single wire, single winding. Previously the winding was there. Okay. Therefore, I'll be connecting the two wires over here, T1 and T2. For this machine, I have connected the R phase, two windings, two ends. Two ends means this will be U and this will be X. Okay. Therefore, with the help of my megger, I will be cranking the shaft. See, if I am going to crank the shaft, if you see the reading, it has been coming to 0. That means conductivity is there. Okay. So, okay, how I can check the megger? First, I have to check whether my megger is being connected, this good or not. Okay, if that is the case, I can have a connection, interconnection, short circuit. Short circuit means we know that the resistance is 0. Okay, therefore, if I am going to crank the shaft, this shaft must be cranked for 160 RPM. Okay, then only the 500 volts will be developed, and because of which the current will be flowing through the circuit which has been made by us, and accordingly the resistance will be measured over here. See, I am cranking the shaft. it's been displaying 0 mega ohm. Okay, therefore this resistance is 0. Now I am going to open it. Open circuit. Open circuit means resistance is infinite. See, if I am going to crank the shaft, the resistance which has been showing is infinite. Okay, therefore I can easily tell that yes, my instrument is working properly. Okay, instrument is working properly. This instrument has a club of 2 instruments. One is ohm meter, the second one is DC generator. Okay, we'll go on to the next slide so that we'll know what are the things can be done. Okay, to check the machines for this particular machine, how to check, what are the tests should be done. If that is the case, I have to do the first I have to do the continuity test. Continuity test. Okay, continuity test means where I have to do, across what are the terminals I have to do. As I told you earlier, this 3-phase winding motor, 3-phase motor. 3-phase motor means 3 windings will be there, R phase, Y phase and B phase. Therefore continuity test means there should be continuity between R phase. R phase means 2 terminals. What are the terminals? U terminal and X terminal. Y phase, what are the terminals? B terminal and Y terminal. B phase is W terminal and Z terminal. For all these terminals I have to measure the continuity. Okay, therefore using the measure, see, for simple and easy thing we have used the same color for the measure for the 3-phase windings. Each phase same color, blue for R phase. See, it's measuring 0 ohms. Therefore for UV it's 0 mega ohm, and for green wire here also it's showing 0 mega ohm, and for black wire or for B phase the resistance is also 0 mega ohm. Therefore 0 mega ohm. It tells that the continuity, the R phase, Y phase, B phase are of good continuity. Therefore first test got over. Second one, insulation resistance must be measured. Okay, if insulation resistance must be measured means I have to take any one set of winding. I can have the starting winding or I can have the ending winding terminals. Okay, I will be taking the starting winding terminals. Therefore I have 3, U, V and W. Okay, therefore I have to measure across U and V, V and W, and then W and U. For these 3 readings I have to take the reading, okay, mega ohms, and it should not be 0. That means, see, the 3-phase windings, 3 windings, R phase winding, Y phase winding and B phase winding. If these 2 windings are shorted, at that time if you measure U, V, W means if you are going to measure, this V and W will be nearing to 0, okay, or it will be more value. Okay, if there is any internal short, it can be easily found out. Therefore insulation resistance will be more high in case of this in between the windings. Therefore I have taken this R phase and Y phase. Okay, if I am going to crank the shaft for 160 rpm, the resistance is some 1 mega ohm. Okay, then Y phase and B phase. Okay, it is showing as infinity. This is 1 mega ohm, this is showing as infinity, and the third one or in this also 1 mega ohm. I'll check it out, U and B and W or YB. Oh, there is a mistake here also, it is showing as 1 mega ohm only. Okay. Therefore, the resistance is 1 mega ohm. We can use the machine, but for voyages, if you are going, then this has to be, maintenance have to be done for this machine, because of some humidity also the insulation resistance might have reduced. Therefore, if you are going to perform overhauling, then it will be good. Okay. The third one is we have to measure the earth test. Okay. This earth test should be done because see, if any wire is coming in contact with the metal body, then if we are unknowingly, if you are going to touch the metal case, then we will be getting shock. In order to avoid that, we need this test has to be done. Okay. Here first the body of the appliance to the body of the appliance, the first reading will be taken. Second, for U phase and the body of the appliance. The third one, V phase and the body of the appliance. Then W phase and the body of the appliance. Okay, for this we will be taking the reading for across. If for metal contact, see, I am going to fix this as a fixed one in the metal contact, and I am going to fix another terminal. Now if I am going to crank the shaft, the resistance which is being measured is 0. That means here it's okay. All the body resistance are being, all the body is being connected. Continuity is being there. Therefore, for the whole body, continuity is being there. Now I have to check whether for each phases whether there is continuity. Okay, the R phase, it's been going to 50 mega ohm. Okay, for Y phase, it's also going to 50 mega ohm. For B phase, it's also going to 50 mega ohm. Therefore, by this reading we can tell that the machine is in good condition, but only thing is that because of the insulation resistance between the winding is less, that is 1 mega ohm. If it is going for voyage, if we are going to take it in the ship, then before which we have to go for overhauling of the machine, and it has to be maintenance have to be done for this machine. Otherwise we can use the machine because there is no short circuit problem. Okay, between the body as well as the conductors, and between each windings there is good conductivity. Okay, and only this value is less, but it's not bad. Okay, therefore we can use the machine. By this I'll conclude that with the help of this Megger instrument we can find the insulation resistance not only with the windings. See, for example, I have a cable which here also I can measure the insulation resistance, so that I can easily tell that yes, this cable is good, this can be used for the applications and all. Okay, I'll use this yellow wire. Okay, for the yellow wire, both the ends I have connected over here. The resistance which has been shown is 0. If you want, you can notice this. When I am cranking the shaft, see, the resistance is been going to 0. Okay, that means it's good conductor. Okay, at the same time, see, here I have kept it in yellow wire itself. Here I am going to change it to red wire. Okay. Okay. See, the pointer is going to infinity. If you notice, the pointer is going to infinity. That means there is no conductivity between this yellow wire and red wire. That means insulation is good. This cable can be used. Okay. Therefore, I think you have understood the importance of insulation resistance and how the measure operates, as well as how the measure can be used for testing the machines and telling the condition of the machines. Thank you.